maintenance logs with blockchain technology. It's brought to us by the FPSA Technology Network. My name is Elena Sierra, and I'm the Director of Networks and Special Project for FPSA. And now for some self-promotion of FPSA. The technology network strives to promote advanced technologies in the processing industry. If you're interested in joining the network, please go to fpsa.org/networks to join it today. If you have any questions about our network or the technology that we're looking into, the different technologies, please don't hesitate to contact me. My email's on the screen. It's esierra@fpsa.org. Before I pass it to our moderator today, here are a couple of housekeeping items. This webinar is being recorded and will be accessible on the FPSA website. All attendees can submit text questions to today's presenter by typing in your questions into the pane of the control panel. You can send your questions at any time during the webinar. Our moderator today is Nehemiah White, and Nehemiah is a marketing manager at Deville Technologies, where in addition to his other duties, he provides sanitary and hygienic design training for both industry groups as well as various other team members of his team. Take it away, Nehemiah.
Thanks, Elena. I appreciate the introduction, and I'm super happy to be here today. Super excited about our speaker today. We've got a lot of brains in the room, and you guys are in for a treat. So Eduard Grün is our speaker. He's worked in software development and agile project management for well over 10 years. Here at Festo, where he works on the development of the economy of things. In addition to that, he's also part of a blockchain focus group where he serves as an advisor to the German government. And he also teaches in his spare time at Baden-Württemberg Cooperative State University. In addition to all these things, specializing in particular in the sharing economy and decentralized digital marketplaces. It's a lot to think about, Eduard, and I'm excited about the topic we have today, excited about the material you have, and you have a lot to talk about. We could cover an entire afternoon in the material you have, so I'm going to let you go ahead and jump in to the material you have and address questions when the time comes. Take it away.
Thank you, Nehemiah.
Yeah.
Have you ever been to a whiteout? I'm a mountaineer, and on one of my last adventures, I got caught by a snowstorm. And in a couple of minutes, everything got snowed in and white. And as the clouds came in, your viewing distance was like a couple of meters. And the best thing to do in such a situation is stand still and wait until weather changes. After waiting for an hour, I decided to turn back and cancel this climb. Unfortunately, the fresh snow has covered my old footprints, and all what was left was my memory from what direction I came. You could imagine how happy I was when I finally stumbled over traces of my old track down to the safety of the valley. Well, with this in mind, I totally understand what the FDA tries to achieve with its new traceability rule. That surely would had helped me when the track would be persistent there. My name is Eduard Grün, and I'd like to welcome you to my talk, Creating Traceable Maintenance Logs with Blockchain. Today, I'd like to give you a brief introduction to the new traceability rule of the FDA, show what this has to do with trust, how blockchain can help, and what we at Festo did to get tamper-proof maintenance logs. But before we start, I'd like to have a little poll with you. So,
Edward, would you like the first poll? Do you have any experience with the new FDA traceability rule?
yeah, right. I tried to start it by myself right now.
Perfect. All right, should we close it, Edward?
Yeah, I think that's enough. So, about the half of the people have never heard about this, so I hope I can help you out with this today. And the other half heard of it, doesn't know how to implement it, and the rest is working on an implementation. So the people who already know about this may help me out when I don't get it that right. So I'm not from the food industry, but I researched a little bit. So let's see what the FDA tries to establish here. The FDA proposed the rule with the name Requirements for Additional Traceability Records for Certain Foods, which is part of the FDA's Food Safety Modernization Act, or better known under FSMA. The proposed rule would help the FDA to identify recipients of foods to prevent foodborne illness outbreaks and address threats of serious health consequences or death. To fulfill this, the traceability rule must be implemented by those who manufacture, process, pack or hold foods on the food traceability list. These foods are such as eggs, vegetables, fish or cheese, but you better look this up at the FDA's website. If you are one of these entities, you must establish records containing key data elements which are associated with critical tracking events. So the big question is, what are those critical tracking events, and am I affected of those, and what data elements should I track then? So there are 5 critical tracking events which must be recorded. These are growing, receiving, transformation, which involves changing a food, its package, and or its label, such as by combining ingredients or processing a food. Then we have creating. This is the making or producing of a food through manufacturing or processing using only ingredients that are not on the food traceability list. And finally, we have shipping. So these are the 5 main tracking events which affect if you have to employ or implement this traceability rule. And for each of these 5 events, there are a couple of dates you have to track for, but this depends on your position on the supply chain. So for the most events, some sort of location and date is necessary, which is indicated up in the first line. And after your plant or your food has grown, more data is necessary to get recorded. For most events, this is a product ID and the description of the food, the quantity in the unit, and the record number and record type must be saved. In the event of receiving or shipping of food, the name of the transporter must be recorded, and if it is an imported food, the entry number is important too. So you may ask, why is this necessary to record all this information? They all exist anyway at those different companies which are responsible for growing or shipping or cooking this foods. So the main problem is that all those different companies have those information, but they also try to hide their knowledge and protect their data behind firewalls, and this leads to companies and factories on the supply chain exchange those data via email or phone, so that they have this information at the supplier or the customer side when they need it. And the problem beneath this is, or to better ask is, what is the problem beneath this? So as everybody needs those data, why are they hiding them in the first place? And the thing is, well, there isn't that much trust in our industry. So when we have an interpersonal connection between people, they know each other, they talk to each other, they do stuff with each other, so they get to know each other and they trust them. But when we transfer this to an digital world where we only see a screen or have only an email address of this other company, we don't have any trust anymore. And this leads us to the platform economy, which we have seen emerge in the last 20 years. So when you go to a marketplace like Amazon, you don't have to trust the seller there, but you can trust Amazon to handle your order and to resolve any problem you have with the seller. So this led to big growing in this platform economy, especially in the US and in Asia. But sadly, we also have what came with this growing is the thing that the winner of such a platform takes it all. So when you remind you back 20 years ago, there wasn't only an Amazon or an eBay to do such marketplaces, but in the end, eBay won this race for auctions and Amazon for reselling. And the thing is, those two platforms are the winners of all other competitors and took everything. So that's, on the one side, it's a good thing, but on the other side, you don't have any more competition when you think how the extremes would work. So the question is there another way to establish trust in a digital economy other than a platform economy? To have an answer to this question, we should look at the business models of such platform companies. So for instance, take Uber. The business model of Uber is like, I need a ride. I put my request on the Uber app, and then somebody comes with his car to me and drives me to my place. So the big question here is, would you trust this nice guy to drive you to your destination? Okay, most people would take the ride. I guess this this picture is that that this guy isn't looking that nice, so most won't take it. But yeah, imagine there is somebody you won't trust to drive you, and then in this case, Uber comes to your help, because now you don't have to trust the driver, but you can trust Uber to give you a secure ride to your destination, and Uber is also guaranteeing you that you will get to your destination. And as we talked about this, you request your ride to the Uber app. Uber will get this request to the driver. He delivers the service, and then you pay Uber for the drive, and in the end, the driver will get his payment. And normally, this driver won't get the full money you send to Uber, because Uber wants to earn something too. So the question is, how can we establish trust between the driver and the client without this central entity, which costs us something but doesn't provide really much that value? And this can be done by technology, especially by blockchain technology. I will show you how. And this also solves the problem with our supply chain, because for now we don't have any trust between the companies, but with technology we are able to get trust between those companies back and let them exchange their data directly. Yes, and I'll tell you, this technology is blockchain. Blockchain is really secure. I'll show you why. Every participant on a blockchain has its own ID, so you know with whom you're dealing right now. Yes, it's a trustful technology. It is programmable. It's tamper-proof, and in most cases, the blockchain also has its own currency. So this leads to my next question. Do you have any experience with blockchain?
It looks like it prematurely closed. There we go.
Oh,
Doesn't work?
Yeah, it looks like it prematurely closed. So
Okay.
that could be
So in this case,
question.
I'll pretend you know nothing about blockchain, and I'll do a quick introduction to this technology. Yeah, let's imagine Alice wants to buy a bike from Bob, and either she knows Bob personally, then because she's her bike dealer in her city, then she may pay Bob by cash, or she doesn't know Bob and she has to find a way to get him his money so that Bob will send her the new bike. And in this case, Alice knows Ted, and Ted works for her bank, and Ted also knows Bob. So in this case, Ted can guarantee Bob that Alice has enough money to pay the bike, and so Bob may send the bike to Alice and get the money. And this guarantee, Ted can get this guarantee also to any other bank customer he works with. And on the blockchain side, all Ted does in this example here is done by the blockchain technology by itself, without any people in the background doing transaction or such things. So the thing is, how can Alice send money or cryptocurrency to Bob? First of all, she needs a Bitcoin or blockchain wallet. I do this example with Bitcoin because it's the most known blockchain or cryptocurrency in this case, and every other blockchain is derived from Bitcoin. So so she needs a wallet to participate at the blockchain or crypto at Bitcoin. And normally this is a smartphone app. You also have software on your PC to participate here. And with this wallet, she has a public key, which is comparable to your banking account. So everybody who has your account number can send you money. And in the blockchain world, that's the same. Everybody who has your public key is able to send you money. And this public key is normally derived from a private key. So Alice generates a private key, and then from this private key, the public key gets generated. And the private key is comparable with your PIN for your banking account. So she's able to certify her transaction with this key. And both of these keys are part of her wallet. So now she has everything to participate at such a blockchain network. The next thing is she needs some money, and typically you get your cryptocurrencies at an crypto exchange, where people who own Bitcoin or any other currency offer their coins for fiat money like dollar or euro, and you can buy the crypto. And what you have to give is your public key so that the other one knows where his coins will go. When she finally got her first coin, she is now able to do a transaction or a payment to Bob to get her bike. And to do this, she simply fills out a transaction like this, where you need an input. That's all those addresses that send tokens to Alice, and you want to use, or she wants to use, to send further to Bob. Then the amount of tokens Alice wants to send to Bob, and finally an output. So that's the address of Bob. So the system knows where this money should go. When she has all that together in her transactions, she sends it out to the network, and then the system will work on this transaction. And this is comparable with your chat. So imagine Alice, Bob, and Carlos want to meet for a beer tonight. When they talk about or chat about this in their chat program like WhatsApp, this whole conversation gets saved there and isn't changeable afterwards. So when Bob wants to come later or wants to move the meeting to a later point, he has to start this whole discussion again. He can't go into the chat application on the different smartphones and change there what he wrote. So the system or all participants have to accept this new meeting time. And this principle is also the basis of the blockchain. You have different nodes there, and they find a common truth which is true for every node. And how do you do this is like you have different nodes in such a blockchain network. So there are the simple users like Alice, which participate with their wallet in the network. Then there are so-called full nodes. These are servers which hold the complete blockchain since the beginning of the blockchain. And then you have so-called miners, and these miners are they work on securing the blockchain so that nobody can change the values on this chain. And what they do is they compute an mathematic algorithm that's called hashing algorithm. And that leads to my next question. Do you have a blender at home? Okay, seems 88% have a blender at home. So, and I can tell you, every time you made a smoothie at home, you employed a hashing algorithm. So the thing of a hashing algorithm is everything you put into the algorithm will generate an unique hashing number. And with this hashing number, you can't calculate back what you put into this hashing algorithm. So that's the same thing with the smoothie. Every time when you make a smoothie, you know there must be a pepper bell, a carrot, some oranges, and when you start to blend all those ingredients, you get this smoothie. But you know what ingredients have been in this smoothie when you drink it. That's, well, I think it's impossible. And that's the same thing with our hashing algorithm here. So they use this mathematical algorithm to secure the blockchain network and to build those blocks. So as the name says it, it's a chain of blocks, and such a block consists of all transactions which were generated or put into the system in the last 10 minutes. Then they take the address or the hashing number of the previous block, and then such a miner tries to find a matching hash. And the matching hash means the system generates a difficulty for, or defines a difficulty for the hash to find. And the difficulty is defined by the given zeros in front of this hashing number. So when there's they do this to make sure that only every 10 minutes a new block is generated. So this means when we have much computing power in the system, then the system will find much faster a new block. So they have to stretch out this time anyhow somehow, and they do this by increasing the difficulty. So when you imagine with more zeros in front of here, you have lesser possibilities to find an accepted hash. And when then there's lesser computing power in the network, they decrease the zeros in front of the hash, so that the system can find a correct block faster. So, and when this miner found in a new block, he sends it out to the system and starts on building a new block on top of this. And this is also how the security and the tamper-proofness of blockchain comes to play. So imagine when I'd like to change something on this chain, and I say I want to change this transaction here and change this hash of this transaction. This means the hash of the block isn't correct anymore, because this calculated hash here represents everything in this block. And when I change something in here, I have to change this hash up of this block too. This means the newer block which shows on this block isn't correct also anymore, and I have to change this block also. And so that's goes through the whole chain, and with each block you have on top of your transaction, it's, well, impossible to change the transaction anymore. Okay, so any questions at this point? So I think that's the complicated part of the stuff.
No questions yet.
Okay, cool.
Your blender analogy is really helpful. So essentially, you have one blender full of product right here in the middle, and Once you dump that blender of product into another blender of product, it gets even more mixed up, and it makes it even harder to change the previous block than it is currently.
Yeah,
Because,
exactly. Right.
yeah, no, that's very helpful.
Cool. Okay. So we'll go on. So as I told you, this miner who found the this block starts immediately to try to find the next block, because he wants to find as many blocks as possible, because with each new block he gets money for his action, or for his work done. Today it's like 12 coins for each new Bitcoin block you find. Actually, currently the one Bitcoin has a value of $16,900 US dollar. So it's quite interesting to find as many blocks as you can. But as every miner tries to do this, you get inevitably such forks in your chain. So this means my last valid block was this one, and then we have two miners which found these two different blocks simultaneously, and they start to calculate the new blocks on their own blocks, because they want to get their own block accepted. And this means now we have to find a way to see which of those forks is the right one. And there is a simple method. The network will always take the longest the longest chain as the true one. So this means this chain will be preferred, and the miner who found this block will get the money. And this has another benefit for the blockchain and the security here. In case we have a bad guy acting on the blockchain, and this guy Chuck wants to pay Alice and Bob with the same coin, and to do this he simply creates a transaction which says this coin goes to Alice, and immediately after this he builds another transaction which says this same coin goes to Bob. And what we have now are two transactions which go through the network and get collected eventually by an miner. And let's say Alice transaction got collected first, and now what the miner checks where this coin comes from, sees here, oh, okay, this coin comes from Chuck and goes to Alice. Chuck is the owner of this coin, and so this transaction is correct, and I will build it into my block and publish it. So in the next round, the transaction to Bob comes around, and the miner tries to build this into his block, and now he checks the transaction, sees, oh wait, this coin which is sent from Chuck to Bob is already taken, and it belongs to Alice right now. That means this transaction isn't correct anymore, and I don't have to build it into my block, which on the other hand prevents the possibility to pay to participants with the same coin. So we have a built-in security measure here. Yeah, let's go on further. Alice has now her new bike and makes a bicycle tour, and on her way she comes across such an lemonade automat, and she wants to drink something, so she gets to the automat vending machine, and as she puts her coin into the vending machine to pay her drink, she thinks, wait a moment, isn't this possible on the blockchain too, to automate some processes simply with the transaction? And yes, this is possible, We call this smart contracts. I brought one to you. This is a smart contract which simply checks if the sender has enough money and then sends this money further to the receiver. But you can do much more complex things with this stuff, like automate complete business logic. So currently we are working on a pay-per-use use case at Festo, so where we observe machine data and then calculate how much the usage of one motion had cost, and we'll do this with smart contracts too. Yes, and that's how blockchain works, what you can do with them. And this leads us back to the FDA proposal. Imagine you go to the supermarket, and there you find a package of sushi, and you buy the sushi, and on the package you find a QR code, and you simply scan this QR code with your smartphone, and what you see on the website as linked to this QR code is the exact location of the catch area, the fisherman caught the fish. Then you see if there was some, if the cooling in the distribution had worked, if there was a problem with the cooling or not. Then you see what the factory has done to the fish, and finally how long this fish laid in the supermarket. And all this is saved to the blockchain, and you know, because of these attributes of a blockchain, that these data is tamper-proof and you can trust it, that this is the truth here. So what did we do with blockchain and maintenance log? So first, we built an application for our customer which digitized the logging of maintenance activities. So in the past, you had all those little notepads or at the different machines where the technician wrote their maintenance tasks into, and if there is a problem with the machine. This was okay, but all those information were scattered around the factory, and finally they landed in the archive, and you couldn't do any analysis on this data. So we have seen this problem and built our app Smartenance, which is well, a digital notepad in this sense. So you can use your your smartphone or iPad to write or log your maintenance activities digitally here, and get rid of all this paperwork. So this helped our customers, but one of these customers is a medical device manufacturer, which gets certified by a medical certifier. And he was totally happy with the solution because now he could analyze his maintenance logs. He doesn't have to deal with all those different notepads. But his certifier told him, well, look, I like that you digitized this complete process here, but we can't trust a digital solution here because we don't know who owns the database where all this stuff is saved, who has access to this database, and who may even change any logs. So what our customer did to circumvent this problem is, well, he wrote all those logs digitally, then printed them, signed by hand, and put those papers back in the archive. And what we see at the FDA proposal here is also that you have to maintain your records either as original paper records, electronic records, or true copies. and they all must be legible and stored to prevent deterioration or loss. So even when you have a digital solution here, you have to somehow make sure that the FDA or any other certifier will trust your solution. So this can be done either by certifying the software development process of your product. So that's one thing we currently look into, or what we did last year by employing blockchain technology here to make your data tamper-proof. So last year we have built a prototype to show how such a tracing architecture and functionality may look like. And what we did is we enhanced maintenance with a blockchain connection. This means for the service technician, there wasn't really a change, as he logged his work in SmartTenants as in the past, and SmartTenants saved those log entries into its database. And now our blockchain solution comes into place. So what we did here, we hashed those log entries in the database and wrote them to the blockchain. And as I showed you, the attributes of a blockchain is that everything that is saved there is tamper-proof and can't be altered anymore. So we have the security that everything that is saved here in the database is saved on the blockchain too. And this gives the certifier the security that he can trust our database, because he knows, well, everything that's on the blockchain can't be changed anymore. So I'll trust those logs in the database, and the customer doesn't need his paper solution anymore. And in addition, he is able to program such smart contracts and automate his audits. So no employer of the certifier is needed anymore to get to your factory and look into your papers if this is correct. But the smart contracts checks this for him. But this automation isn't only possible for the certifier, but also for you and your supply chain. So imagine when you put IoT sensors into your trucks or your mail. These sensors may stream their transport conditions, to the blockchain, such as temperature in the truck or in your package. And then you have a smart contract running on this blockchain, which observes those transport conditions. And when they see that there is a fault with these conditions, like your cooling temperature wasn't low enough, then this smart contract could trigger contractual penalties automatically. So you don't have to check your delivery in your factory if the fish is okay or not, but you see this digitally and automated in the blockchain. So with our solution, SmartTenants, you save time, as you don't have this paper work to do anymore. It's efficient because you have a centralized solution here. Every employer, everyone in the team knows how to handle this. It's location independent, as it's a software solution, and in the end, it's a cloud-based solution. So you could even check your statuses from home when you want to do this. And it's Industry 4, but already as you're able to automate maintenance processes with this product. You could have a test account when you register at this URL, and yeah, So we are working on to get this blockchain prototype into the product so that we can offer such tamper-proof logging mechanisms to all of our customers. And yeah, that's for me. Thank you for your attention. And when there are questions, I try to answer them.
Fantastic overview, Edward. And again, the overview of blockchain and kind of giving us an idea of it. I know you and I talked before this webinar, but I mean, just for the sake of the attendees, I mean, I personally didn't have a deep understanding of it, but understanding the difference, the different points in the chain where information is stored and hashed and verified was helpful. Now, a couple of questions that I had. One was, I don't see any questions right away, and I'd encourage you, those of you who are listening or watching, that if you have a question, go ahead and type that out in the Q&A box. But in the meantime, while we wait for some of those, one thing I was curious about is you mentioned that false transactions, like in your analogy of Alice looking for a bike, you mentioned the bad guy sending 2 different transactions, and that the second transaction would be blocked and wouldn't be written to the blockchain.
Yeah,
so
right.
the automatic question in my mind is, how are false or duplicate entries tracked if they're not written as part of the blockchain, or is that where it would break down then, the analogy? For example, for a maintenance log, if somebody came in and said they had maybe duplicate entries on a maintenance log for a specific piece of equipment, like a critical maintenance piece. But in the blockchain, the automatic analyzer, that's built into the software says, oh wait, this looks like a duplicate, I'm just going to block this.
Yeah.
Would it just block it and it wouldn't be existing, or would there be a way to track that?
That's a problem you can't solve with technology. So we in computer science, we are talking about the Oracle problem, and you have this problem with any database. So you don't know what is the ground truth. Yeah. So you don't know what is the guy typing into this database. And so when you have a faulty or a bad behaving employer, employee, you sadly can't check this. Maybe there is an artificial intelligence you could find out what is true or not, but the simple process of saving data won't provide you any benefit here.
So this whole process is based off of 100% based off of input. So it's 100% dependent on correct input.
Yeah, right. So
okay.
You have the same problem with paper too. So
yeah,
yeah, when your technician is writing down some faulty values, who will check this?
Right, for sure.
Yeah.
But the checking, and I think that's, you alluded to it, but you had actually expounded on it in our earlier conversation, that within the software, there's built-in audits. Basically, I think that's the way you called it, is there's a built-in auditor, so that you don't require an outside auditor to come in and check that information. That built-in auditor basically vouches for itself, right?
Yeah, right. So when I talked about this example with your supply chain, where you track the transport conditions of your package, like is your fish cooled correctly? You have this IoT temperature sensor in your package, which streams continuously the temperature of the truck to the blockchain solution. And then in the blockchain, you could write a smart contract which says, well, when the temperature drops or increases above, I don't know, 6 degrees or what is okay for fish, then this means the delivery isn't good, and dear transporter, you don't get any money from me in this case.
Right.
Without checking the product as it arrives at your place.
Okay.
because you have this information in real time already in the chain.
Sure. No, that makes sense. That's helpful. And that kind of internal auditor is helpful because I guess it shortens the amount of time, or shortens
Sure.
limits the amount of cost to companies for this blockchain technology.
Yeah.
One question that John had was how blockchain technology will impact payment between companies in the future. So I think you had given that analogy between individuals, and you had given the analogy of businesses, companies that don't really trust each other, but with blockchain they can. And I'm dealing with this right now. You have a client who owes a down payment in order to get a project started, and do that ACH, or you can do that via check. How does blockchain impact this whole transaction between companies?
Yeah, so I told you about this use case we're working right now, like pay-per-use. And here the idea is to get all data and information to the blockchain, which also has a cryptocurrency on it. And then in the best case to have like tiny micropayments for each movement, like our drive went out for 20 centimeters, that will cost you like 0.3 cents. And this is possible with cryptocurrency because you don't have that much transaction cost in comparison to a traditional banking account. That's not the problem for the technology. This is absolutely feasible to do. But as you told, for your private accounting, I would say, you aren't that you don't use cryptocurrency for your payments right now, aren't you? Right? And
like for in between companies, we're using, I guess, real money, but it's the money that's in a bank, right?
Yeah, and that's the case for companies also. So most companies are much more conservative than private people. So to have a solution for this, we simply collect all those micropayments, and then the customer will get an invoice once a month, so he could pay this with real money. Yeah.
Okay,
so that's the way we have to handle it right now, but we'll see what the future will bring. So when you hear all those visionary guys, they tell you everybody will pay with cryptocurrency, but we have to see what's the truth.
I guess there's a follow-up question to that. This one says, I can understand how transactions would be verified for digital assets, but how do you prevent the blockchain certified physical asset from being swapped out with a non-certified asset? For example, let's say the asset is a fish and the blockchain is tracking organic, sustainably harvested fish. The blockchain certified fish could be swapped out for non-organic fish using the certified fish label marketing RFID tag, and then the certified fish could be sold on the black market as organic, meaning the seller gets the higher value for both fish.
Yeah.
You understand the question?
Yeah, so there's a project to prove this for whiskey.
Okay.
They built an IoT cork, I would say, which sends a signal to the blockchain when it gets opened. So for sure you have to find another way to get to the good stuff and fill it up with something else. But yeah, I would say this will be you will see this on the bottle then. And so
the cork basically the cork is smart. So when it's opened, then it writes a log to the blockchain.
Yes, and when you then scan the QR code of this bottle, you see, oh, okay, it has been opened once, and then you could guess that that the stuff in it isn't the real one.
So then, say an example for John's example of fish. So if that you could say you took the label off of that fish container and slapped it on an uncertified organic, and then took that certified organic and then took it somewhere else,
Yeah.
that you can't prevent that human action of taking off a label or whatever, but this goes to then packaging security, right?
Right.
So then this then addresses how secure the packaging process is for any of the foods or
Yeah,
items that you sell, right?
So in principle, that's another Oracle problem here too. So you don't know what is going on in the real world when you have a digital solution. What one solution could be is like tattooing a code onto the fish's skin or something like this, when this is even possible. But
yeah, no, that's true. I mean, we're always looking for fail-safe ways to input traceable logs within things, RFID or whatever it might be.
yeah,
At the current time, you have to have some sort of fish. I mean, you have to have some sort of packaging for that fish. So then you try to design that packaging in such a way that you can verifiably or reliably utilize blockchain,
yeah, right.
so that human error or human actions don't invalidate the security of that blockchain.
Exactly, yeah.
That makes
So
sense.
that's more or less a completely different problem than having a secure digital solution here.
Sure.
Yeah.
That makes sense. We're coming up on time, but I want to ask one thing. Apart from people connecting with you directly and maybe testing this out on via a trial or something, there's two questions I have. How best can OEMs incorporate this kind of blockchain technology, like for their maintenance logs? And number two, how best can processors incorporate this technology?
Okay, for maintenance log, I would say use our product. So we're working on getting this feature into the main release. And the more customers are there which require this, the faster it'll get. And the other thing is how to get this into your process. Yeah, that depends. When you use this maintenance tool or smart tenants, you aren't limited to use this only for machine maintenance. So we have an insurer is the customer of us for this product, and what he does is like logging if all fire extinguishers are
up to date,
are certified or could still be used at their insured places.
Right. Okay.
So anything you log some data that's a safe haven for it, I would say.
Yeah, I guess a follow-up conversation that would be interesting to have would be implementation of this data or of this technology. So we see the technology that's available, we see the possibilities of it. Now, how then do we implement it? So a lot of the audience here that is listening today is our OEMs. That's the primary membership of the FPSA. Okay. But for the broader processing industry, that would also be a good question. So I guess I'm going to go ahead and hand it back to Elena. We are pretty much on our time, and Elena's got a few more words for us before we cut out.
Yeah, before you guys leave, we just want to let you know about our next webinar, Be the Inspired You, Identifying and Owning Your Personal Skills for Professional Success. It's going to be on Thursday, December 3rd. You can go to the FPSA website to register. Raquel Shelton, an author and workplace advocate, will be the host of that webinar. And beyond that, thank you so much for joining. Thank you, Edward, for all your knowledge and explaining blockchain. I think we learned a lot, and also explaining how SmartSense works. We really appreciate you.
Thank you for your invitation. It was a pleasure to speak here, and hopefully there is another opportunity.
Yes.
Absolutely.
Yes.
Thank you, Edward. Thank you for those of you who attended. We look forward to seeing you at the next webinar.
Yes. Thank you, everyone. Have a good afternoon.
Bye-bye.